Stairs are undoubtedly one of the most complex things to model in Revit, and probably the hardest system-based family, for the very reason that they have a number of different family parameters and components, and there are multiple types of different subcategories that go into making a stair. So before we go creating a stair for this house that we're doing, which is actually a very complex stair to draw within Revit, let's just go through the stair command as a whole. So the stair command is found underneath the architecture tab. About halfway across, you have this little palette in the ribbon for circulation, railings, ramps, and then stairs. So when I click on stairs, it brings up the sketch palette, and then you really have to pay attention to the properties window and the parameters set within there, because by default they may set to different locations that you're not wanting to actually draw from and to. So within the type selector, this is Revit out of the box. This is the same project file I've been working on. There's a couple of different stairs within here, and they're fine to start with. But as time goes on, you'll progressively get more and more stair types. And we're going to go through essentially how to draw stairs generally, then how to draw stairs for commercial use, and then we'll go through the stairs for our brick veneer house, our two-story house, because again, as I alluded to, it is probably one of the more complex stair types. So I'm just going to choose the assemble stair, just the 190 max by 250 going. And then in the sketch palette, you've got the different modes that you can sketch within. So you have the ability to draw a run, to draw a landing, or to draw supports. So already you can see there's 3 different families even within here. Then you have the ability to draw straight sections, curved, or like spiral stairs, half spiral, L shape, and U shape. And then the final option is to just sketch the stair in its entirety. And as you hold your mouse over each one of these, there's like a small video that loads that will show you how that workflow is completed. Underneath of that, you've got the green options bar, which is always good to take a look at. So the location line, the moment it's from the center, but you can see, much like with how you draw walls, you have different options of where that location line is. The same deal again here. And then you have the offset, and then the actual run width, and then whether the landing is automatic. The other thing to take a look at before you start drawing, and it is important to do this before you start drawing because changing it after the fact is always pretty tough, is the constraints. So take a look at your base and your top levels. So the base level is ground floor, and the top level is ground ceiling level, which actually we want to be level 1. Then underneath of that, we'll have the desired stair height, and then underneath that, the desired runs, the actual number of runs, the actual height, and the actual tread depth. So what this looks like is, let's just go with run, and I'll just do a straight set of stairs. I'm going to click once and drag my hand up the screen, and you'll see that Revit will automatically count the rises. You can see down the bottom in grey, it says 9 rises created, 8 remaining. And so I have the ability just to draw the entirety of the rises, or the entire stair, and then click again to finish, and now that stair is done. And then you'll see in the properties that I've got the desired number of rises of 17. I can say less than that, but what will happen is that the stair will have to rise higher than is actually permitted within the NCC. So if I said, actually, I want this done on 15 rises, you see the riser height is now 210, and I'll get a warning saying the actual riser height of the stair is greater than the maximum riser height specified in the stair type. Note that the stair type is 190mm max rising or riser. So you can either cancel that and it will revert it back, or you can go ahead and click OK, and essentially Revit will allow you to do it, but it's kind of like your funeral, you know, like this is a non-compliant stair now. So I'll go back, and where that rule comes from is under Edit Type. You have in here calculation rules, and if I click on that, it brings that up. You know, your R plus R times G equals going or something. I can't remember exactly that. Riser plus depth. No, I can't remember the calculation, but you are able to put in your min-max calculations here, and it's good out of the box. It's to Australian standards, so that's great. Then what we'll look at is the tread width. So by default, it's got a minimum run width actually. So the run width is 1,000. You can change that on the fly, like so. You can change it from the quick dimension as well. There's a few ways you can do it, and even when you draw, you can change the actual run width as well. So there's a few ways that you can do that. So from here, let's take a look. Okay, let's take a look at this in 3D. So I'll click OK, and it's going to look like this. And I'm going to go BX for box to make a section box around our object. And then I'll just turn off the section box so it brings everything back. So I'm in our file. I'm just drawing away from our house at the moment. So this is just a standard assemble stair, and it's just one consistent run. Let's go back to our ground floor plan and do another stair next to it. So I'll go stair, and this time I'll go from the same place. I'll just eyeball it for now. I'll come up and I'll go like say 6 rises. I'll click once. And now what will happen is you'll see that like I still get this snap of where my cursor is. I can leave a landing, so let's say I leave 1200 or 1.2 meters, and then click once more, and you'll see again the rises continue on. So 3 rises created, 6 remaining. So I can go all the way to the top, click, and you see that landing has been created automatically. Click OK, and what I'll do is I'll just align these 2 stairs just for organizational sake, and then go back to our 3D. And you'll see that's what that looks like with the landing now automatically sketched and created. All right, next up, let's try again. Let's go stair, and this time let's do like a U shape. So I'll draw one set. Oh, there's one key metric that I forgot to mention. As I go back and drew those last stairs, notice the top level reverted back to ground floor ceiling level. This is extremely annoying. This happens a lot with stairs. It reverts back to the default. Whether it's this or other parameters, it always reverts back to the default. It's very frustrating for any instance parameters. So I'm going to go back to level 1. Let's go again. I'm going to come up to say 9 rises created, 8 remaining, and then come across to here. So I've gone 1 riser down, and then draw the other way so it finishes off nice and cleanly. So in line with our first riser. Click, and now it's complete. And now I've got my U-shaped stair, and I can change the widths of these, the different locations. So I can click on this row of what you would call this run of stairs, go move, and then just simply move that back. I could dimension the distance between these two, which is currently 450. Click on that and then update that to be 150. That's very tight. I'll make that maybe 300, something like that. And then again, click OK. And now those U stairs are completed. Go back to my 3D. I'm just going to move this across a little bit. Go back to my 3D, and there's my U set of stairs. Now, even within here, notice that you can select a multitude of items at once. So you've got the stairs themselves, that's the same. Then you have the stringer, the supports, and then you've got the railing as well. And they're created individually. And then within this stair, you've got different types of treads, different types of goings, and different types of rises, different type of landings, different means of which they connect to the top and to the bottom of a stair. And then the railings as well. There's a multitude of ways that you can use railings. So what I'm going to do is I'm going to go through this as it pertains to like a typical set of like compliant stairs, just to get your head around it, and then you can experiment with it from there on. I'll leave some resources in the description of this video to other YouTube Revit tutorials pertaining to stairs. I mean, even Autodesk's own stair course is around 5 hours just for stairs. So it's an incredibly complex component of Revit. Even within firms, it's generally left to the real guns, the real Revit guns, to utilize this, because it's both a highly compliant area, constraining and compliant area, on top of being an incredibly complex area within Revit as well. So let's take a look at these after the stairs have been made. So if I click on one of these stairs, you can see going from ground floor to level 1, desired number of risers, all the rest of it, that's fine. But if I click on that and then click in the modify panel, edit stairs, the railings go, And I have the ability to now select the supports individually and the stairs as well. Plus you can see there's this run arrow as well. But when I click on the stair, I have the ability to say I can begin with a riser or end with a riser. So you'll see what that means here. So if I turn off begin with a riser, the stair starts with basically a run, essentially, which almost is very rare that actually happens. So you start with a riser, but then at the end, it does make sense. You can say end with a riser. So you got one riser coming up before you meet the floor, or you might say don't end with a riser, and it's actually one of the stairs is equal to the top of your landing. In which case, I would need to go back into the stair and just recreate that to make sure that that is finishing at the desired level. Okay, then underneath of that, I've got my run width. So again, I can change that to say 1200. And then in gray, it's reporting that the riser actual height is 185.3 mil and the tread depth is 250 mil on the spot, which is minimum standard. The actual number of risers is 17 and the actual number of treads is 16. If I go back into my ground floor plan, I can continue to edit this too. So let's say I go end with riser. No, I would not like to, but I need to come up one more stair like so, and then go back to my 3D. So I know now that this top stair is ending at that correct height. Okay, when I click the green tick, the handrails then come back. I have the ability to edit handrails within this view as well. When I'm creating a stair, I don't have to create handrails while I make the stair. They're associated to a stair type. But I'll leave railings for a second because that's completely different. So let's take a look at these stairs in particular. So this is common throughout all types of stairs. So the two types of stairs I'm going to show you are assembled stairs. That's what we're using right now. So think of your typical timber staircase and the different options there. Or it could be a tiled, like with some really nice slate tiles or something like that. And then I'll show you a monolithic stair, which is more like a concrete stair, either precast or cast in place. So with these assembled stairs, I can click on the stair run. We can go and edit type, and then you'll see there's an area for tread material and riser material. And then underneath that, you've got treads at all, and then the tread thickness, and then even the profile, the nose length, and the nose profile. So I'm going to zoom in relatively close so we can really see what each of these things do. And I'm going to turn off one of these supports, just hide. I'll delete it for now just so we can see. I'll turn off line weights and then take a look at these. So go on to edit type, and this is really just experimentation. There's no right or wrong here. It's just about playing with it. So let's go where are we? So the run type is a 50 millimeter tread, 13 millimeter riser. So this is the run type. So it's a 50 millimeter tread, which is this component here, and a 13 millimeter riser. And this is what I mean by these are really complex families, because they're like families within families. So this run type is actually a family type. So when I click on this, I've got the three buttons and I click on that and it opens up another window. So you can see there's our original stair window. Here is our family, our system family, just for the tread type. So we can duplicate this and we might call it something else. We might say it's a 80mm plus, so 60, so I don't know. Let's say it's a 30 millimeter tread and a 30 millimeter riser, just as an example, okay? And we'll go okay. And then here I can say the tread thickness, we'll change that to 30. I'll say okay. And then I'll say apply. Now notice that that tread thickness changed. Let's go back into there because this is now the new type of run family that we're using. You've got the profile, which I'll leave that for now. The nose length I can make like say, let's say I make it 50 and say okay. And what happens is that the nosing for that tread gets longer. So you have like this undercut. So it may not be 50, it may be like 15. Something like that. So you can see that's now overhanging 15 mil. I also have the ability to change the profile of the nosing itself, not just the tread. Okay, But underneath of that, I then have the risers too. So let's change that first. We'll leave that nosing length at 15, but I can change that nosing profile. I don't have one loaded in, but that's how I'd give it like a bull nose, like a rounded edge or something like that. And then underneath that, you've got the risers. So I can even turn off the risers completely. So if I do that and click apply, you've got something that looks like this. So a typical riserless or just treads in your stairs. I'll turn that back on for a second, and then I'll turn on this thing here. It says slanted. So I'll click on slanted, and then you'll see now that they're actually angled, but they're going to meet the front of the stair. Okay. And this is typically what we do for our concrete stairs. Not really with timber, but I'll do that for now. I'll untick that, and I'll change that also to 30 mil. So we'll thicken up that riser. So it looks something like that. Then we can change these materials. So let's say, for instance, the tread material, for argument's sake, I'm just going to give it... let's just go rename PM stone. This is just on the fly. And then what pattern can I give it? Give it like a dense sand hatch or something like that, because why not? Say apply, and you'll see now that's updated there. And then the riser material, duplicate it, call it stone 1, sure, and then I'll change that to like a white stone. Okay, and then apply, and you see that's updated now too. Alright, so that's how that's done. And then you've got also the riser to tread connection, whether it's behind the tread, extended under the riser, or join all risers and treads. Okay, so I can play around with these. I'm not exactly sure what each of these ones do off by heart. Oh yeah, you can see how that changes the join here. So whether the tread comes through and then the riser joins, or whether it's like a butt join. Yeah, this is really good for detailing. That's probably more typical. But, you know, it really comes down to detailing, but just know that that's how you control it. So this is all under the 30 mil tread, 30 mil riser. And to be honest, with these materials, I'd be putting the names of the materials within the tread type, because I could have two stairs which are exactly the same, but one might be carpeted and the other one might be tiled. And I would need to make sure I've got two, even though they're the same dimensions, they need to be two different types of treads. So yeah, let's take a look at wood steps 50 mil. What does that look like? So, okay, so that's a good example there of where you've got like that bull nosing profile. So let's take this is one that's in Revit by default. So you'll see here nosing profile, M stair nosing, radius 20 mil. So that's what's giving us that profile there. But let's go back to our one. So okay, apply. That's our one again, and I'm just going to change this to a timber material. PM timber finish, timber floorboards, timber cladding. Let's go with the floorboard material, but I'm going to duplicate that and just call this timber finish. And this will be TB02 because it's the second type of timber finish, and just get rid of that. Pattern, no pattern, okay. And I'll give it the same. TB02. There we are. Apply. That's better. So we now just go to our timber finish. Okay, so that is just our run type. Then you've got the landing. So I'll click OK, and then I'll come up. Actually, I'm going to go to one with a landing. Notice as well how the other stairs updated, because we essentially, for this type of stair, this assembled stair, we changed within the type parameters what type of run is associated to that. If we wanted to have different type of stairs, we would have to duplicate it and call it like this one. And then this one might have, this one might have the timber step, the default Revit one, like that. And now you got these two stairs which are separate. But if I click on that, that's 90 by, That's the same stair we used going to. I just duplicated it and just called it whatever. And then this one is the original. So you have to be aware of that. Okay, but I will go to here and change this back to the other one we were working on. And then go edit type. And then so under landing type, you've got the same 3 buttons you click on. And then pretty simple, you can say it's either the same as the run, you tick that box, and if you untick the box, then you have the ability to change the tread material. So what material is that landing compared to everything else? What thickness has it got? What's its profile? You know, how does it join to the other risers? It's up to you. Most of the time, I got to say that it's the same as the tread. It's pretty rare that it's not, but just keep that in mind. That's how you adjust the landing in stairs. Next one is whether the function is interior or exterior. You can change that as appropriate. You'll also see, actually above, I didn't cover that, you've got the maximum riser height, minimum tread depth, also the minimum run width, so you can't make it smaller than 1,000 wide. These are great for your compliance components too. But just keep in mind that minimum run width does not include handrails, so keep that in mind for your handrail clearances. Then you have the supports, so which supports are there by default. So I'm just going to go back out and I'm going to isolate this stair without the handrails and go back to edit. I'll move it across and then go back to edit type. Okay, and then you've got the right support, the profile of the right support, and then the left support as well. So we could turn this and say, actually, you know what? Let's just edit this for a second so we can see this. I'm going to turn off the risers in this stair. So it looks something like that. And then you've got the right support. You can say there's one or none. So you can say open carriage, like so. So what that looks like, I'll change that on the other side. Stringer closed. So if I turn the stringer to open, like an open carriage, take a look here. It cuts to the profile of the stair. Or I can say that there is none and go like that. And if I do that on the other side, it looks something like that now. But I can then give it a middle support, like so. And I can even change the amount of middle supports that there are and divides them from the center point outwards. Normally it's just one, like so, if you've got like a floating stair like this. Okay, and then you have carriage 50mm width. Okay, and I'm going to turn that off. And I'm going to turn the 2 supports back on. So I'll say stringer closed, stringer closed, stringer 50mm width. Now in here, this opens up another box, and this is the type of stringer that you're using on either side of the stair. So again, you've got the material. So actually, before I do that, I'll click OK, click apply. So we bring back these, and then I'll go to one of these, stringer 50mm, and I'll give this the same timber material. There it is there. Say OK. Click apply. That updates those stringers to be the same material. Then you've got the section profile. And the reason why the section profile is there is because you can turn this into like C channels or something like that. It's pretty typical for like industrial stairs or plant room stairs or steel stairs. If I click on this channel C250 by 300, a C profile, and click OK, we want to flip the section profile. So I'll flip it. And then you'll see now that's turned into like a steel C channel beam essentially. But that profile is set. And then you've got the structural depth of that. So here you'll see that this isn't quite sitting right. These stairs are sitting above the C channel, and so is the landing. I can change that depth. So say here the landing, I might say 0. Let's see what happens. That lifts it too far up, so probably 250, 125, something like that. Yep, that works. And then I'll do 125 here. Probably a little bit less, 50. Yep, so this way that your stringers are encased within the riser itself. So that's pretty good. That's actually looking a lot like a steel staircase. But anyway, let's turn that back. So because we're all editing this under the stringer 50mm. In fact, I could just duplicate this real quick and call this one stringer C channel profile, or C channel 250 by 30. Okay, so I've got that one for later. And then the original one I've got to change this back now, so I'll change that to default. And then you can change the total depth and the width as well, because this is just a regular rectangle as well. So I don't have to flip the section because it's the same section either side. It reverts back to how it was. I'll change these again. So what was the depth there? 300, I think. Yep, that looks good. You've got the width, so I can make that only 18 mil if this was like just finished timber, like so. Or I could make it like 150 mil, like that. So it's all just about experimenting. I'm going to leave that at like 18 mil, and I'm going to change this name to 18 mil width. Okay, so that's now done, and there's plenty of other options that you can just play around with there to get the look that you're after. So I'll say okay. I'm going to go back to my stair, and I'm going to turn back on my riser. Okay, so I've got something that looks like that. So those are the stringers, and I can have different stringers on the one side or on the other. And like I said before, I might say, actually, I do want a stringer, but the stringer I want is actually going to be the C channel on the left-hand side. So click OK. Now I've got one channel, one side I've got timber, the other side I've got the C channel. Or I can just turn around, I'll change that back. Or I could just turn around and say, you know what, I want an open carriage on one side, like that. Or I just don't want anything on that side, like that. So there's lots of customization, but realize that these are all type-based parameters. So if I want one stair with something here, another stair I want stringers on both sides, they're two different type of stairs, even though they are the exact same type of stair. So just keep that in mind. So I'll leave that as, and then everything else is pretty much good to go. So I'll click OK, and that's the stair, a timber stair, sort of preliminary completed, just out of the box. Bring everything back, and then you've got handrails. And so handrails, there are a multitude of different types, and I'm going to go through just sort of the basic of like a basic pipe and how to run with that, because that will be for your commercial stair. But I'll go through that when we go through the commercial stair itself. So that wraps up, I think, stairs just as a whole in terms of what is selectable. But again, we haven't touched on handrailing yet. That's just stairs. And so next up, we'll go through how to do a monolithic concrete stair with a typical pipe handrail profile. So these are an old set of compliant fire escape stairs, and I'm going to do this in sort of real time. I'm going to build up these stairs and show you how to do it using the monolithic stair tool, referencing back to these drawings just for some quick dimensions and sizing, but noting that this is a 4 meter floor to floor level and we're working with 3. But again, this is just for demonstrational purposes. So I'm going to get rid of these, go back to my ground floor, and I'm going to go stair, and this time I'm going to choose a cast in place stair, or you got the precast stair. I'll do cast in place. To be honest, the difference is not huge, it's just in the joins really. So I'll say monolithic stair. I'll go from ground floor up to level 1. That's fine for now. I'll go edit type, and I just want to make sure these rules are okay. Max height is 190. Minimum run 250. Minimum width I'm going to put as 1200, actually as 1100. And then you've got the landing, the run type, the landing type, some other functions there. Let's just leave it at that right now. I'll say okay, and we're pretty much good to go. So I'm going to go across. I got 9, 8 remaining, so I'll go up to 9, and then I'll come across to here and cut one back, and then go the other way like so. But I've got too many here, so what I'm going to do is I'm going to drag that back. Oops. Alright, how are we going now? Let's just go to our 3D. I'm going to get rid of the handrails right now. I've just deleted them. How is that looking? That looks pretty good, I think. Let's go to ground floor. I'm going to just cut a section It's almost always you need a section while working with stairs as well, because you need to view it like that. How high are we going from top to bottom there? Too low. Okay, so go back to here. I'm just going to draw those again. Stair, make sure I'm going all the way up to level 1. There we go. Alright, cool. I'll drag that back. And that's fine where they are. Say okay. And then I'll just move this up. So it's going through the section cut. And that's much better. Okay, I'll delete the handrails again. I generally think it's better to just draw your own handrails, but that's just my personal preference. Everyone's slightly different. Okay, so let's edit these a little bit more. So this concrete set of stairs, I'm going to go edit type, and then we're going to go into our run type. So I'll go to here. Underside is smooth, and there's a structural depth. So if I say stepped, keep an eye on what happens to the underside of the stairs. Say okay, and you'll see that those are actually jagged now. They follow, which is almost never the case. The structural depth, as the name implies, is the depth of the stair. So if I change that to say 250, take a look at the depth of that stair there. It becomes much deeper. 150 is pretty standard. I'll say okay, or in fact, really it's 180 or something like that. Like so. You got the material, it's just a monolithic concrete, so that's fine. The treads, are there any treads? And you can say okay, and what that does is actually puts a tread on top of the stair itself, and this is pretty typical if you've got like a, you can do the same thing with the riser as well. So I'll say riser, and that comes up, and this is how you get like stairs that are monolithic, but then you've got like a tile finish. So think of like in a shopping center or an office building. Think of a shopping center. You normally have like stone tiles that sit on top of the concrete step. That's how you would do that. But in this case, we're just running with just a monolithic stair. We are not going to have a nosing profile, but we are going to have a slanted riser. Okay, but we do need a nosing length of 20 mil. So we get something that looks like this. And I'm getting that from the set of drawings. So if I go back to here, I can see that I've got a 250 millimeter riser plus a 20 millimeter splay. So that's what we're doing here. And you see the thickness is 170, the throat. I've given it 180. That's probably more realistic. So I'll just get rid of that. That looks okay. And then you've got the landing, which is 300 mil. Again, generally the landing will be the same thickness. So I'm going to rename that, and this will be 180. Okay, change that to 180. It's the same as the run. 99% of the time it's going to be. There we go, it updates. That looks great. No supports here because it's just a monolithic stair. You can have, but in our case we don't. So that looks good. All good. I'll go back to our ground floor. I'm just going to quickly just draw a slab. Handrail concrete slab. Okay, something like that. And then copy that. Sure, something like that. Okay. Then what we'll do okay, it's fine. All right, then what we'll look at is handrails. So actually I might just hide that for a second. So with rails, I can just click on a set of stairs and say edit stair. And then I can go over to railing, although railing's not actually appearing at the moment, which is fine. So I'll get back out of there. What I'll do is go back to my architecture tab and then go over to railing, and then you got sketch path or placed on a stair or a ramp. So I'm going to place it on a stair, and then it's going to ask me, do I want to put it on the stair, on the treads or the stringer? We don't have a stringer, so it's going to be on the treads. So I just click the host, and then those stairs now appear back to where it was. Railing is incredibly complex as well. First tip, utilize 2 rail types for the interior and the exterior of the stair. A common mistake is that people try and utilize the same rail family for the inside and outside of the stair when the conditions are just different between the two. So I'm going to start with the exterior stair like so. I'm going to change that to a 900mm pipe like so, and then we're going to edit this. So I'm going to click on this and go edit type and duplicate it, and I'm just going to call it pipe 2. Sure, that's fine for now. And let's take a look at this. Now, this is no different to the stairs in the sense that there's type properties within families, with components within components, and etc. So the rail structure at the moment, these are these rails along here. 4 rails, that's 1, 2, 3, and 4. It's not the top rail, that's separate. So I'm going to get rid of these, and you can see as I click on them, they highlight and they've got the height between them. So rail number 2 is this one here. I could make that say 450. And I'll make this one 500, make that one. Apply, and you see how that looks now, okay? But I am going to get rid of these. I'm going to say delete, 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 and okay. And so it looks like this. Next, you have the baluster. So these are the balusters here, the things that go straight. You can change those. So at the moment, that's just a baluster by itself, just a round 25mm circle that's extruded. You've got 20mm, you've got square balusters. You can choose to have none. There's a bunch of different ones. So you could do like a glazing one. So if I go like that, it turns that into a glazing panel. But for this project, I'm going to say none. Okay. You got where it's hosted and then the previous distance. So the baluster here that's showing here, this is the main pattern. This is the regular baluster. The area at the bottom, the reason why you're still seeing these two is because this is the beginning and the end. So you can see here that they've got one at the start and one at the end. I'm going to say there's none. At the corner, there's none there. And there's none there. So I'm going to do that, hit apply. I'm just going to end up with a rail that looks like this. Okay. I'll say all right. Okay, so let's talk about that. So you got the top handrail. Yes, we are using that. Rail connections, are they trimmed or are they welded? I'll show you what that looks like at the end. The angled joins, add vertical segments, no connector. That's a tough one to explain right now. What that means is when 2 handrails are near each other, they extend and join, kind of like trim extend. Same with here, extend rails to meet at tangent joints compared to angular. Both of them you want to treat the same. Use the top handrail, yes, the height is 900. We can say actually we want it to be 1000. Say apply, nothing really. You can't tell here because there's no reference to a ground plane. The type is a circular 40mm handrail, so I can click on that, and now that brings up the handrail or the top rail type family. So at the moment, the default join is a mitre, but you can change that to fillet, and I'll do that shortly so you can see the difference. You got the clearance, which is minus 20mm. I just want to double check what ours is. It should be 50mm minimum, I think. I think there's 5mm in there for tolerance. So let's do 50. Okay, the profile is a 40mm profile, but we could change it to a 30mm hand profile as well, but I'll leave it as 40. The transitions are simple. The material, there's no material on this pipe at the moment, on this handrail, that's fine. And then you have the beginning and the end extension. This I'll show you once we actually put this on the stair. and then the terminations as well. So I'll say okay, because that's where most of the complexity lies. Then you have the handrail number 1, number 2. So you can have rails that are within, but then you also have set handrails as well, the top handrail, second handrail, etc. Yeah, they're for much more complex balusters or railing types. So I'll say okay, and that's all that happens right now. And you're kind of like, all right, well, that looks cooked. What's the go here? So firstly, let's take a look at the miter joints and whatnot. I'm going to change this as well to that pipe type, and it looks something like this, which is correct because we've got the going before we start rising. This is why you have that nice clean handrail junction. So with this like that, I'm going to give this firstly a fillet. So I'll click on the handrail, edit type, go into the handrail type itself, the top rail, click on that so it opens up this family, and let's change that to fillet. And the fillet radius will make 40 mil. So okay. Well, can't contain. Why not? What about 50? Yep. There we go. And you can see now over here that the handrail is filleted. So okay. And it's filleted around here too. Well, it hasn't done it there, probably because that area is too tight. But we can double check that. So I'm going to go back to my ground floor plan, and I just want to double check the offset here. So between here and here is 35 mil only. So I'm going to click on that, and I'm just clicking on the handrail in plan view. And particularly I'll do this one here, and you can see the offset from the path is only 25 mil. So what I'm going to do is I'm going to change that to 50 mil. The pipe grows, and you'll see now because the pipe has come out, or the handrails come out, it can now fillet it. So let's just double check that distance. That's 60, so I need to make a quick adjustment. That will actually be 40. Beautiful, 50 mil offset. And then I'll do the same thing for this pipe as well. So 40 mil. And now I've got a nice 50 mil gap for my hand between there. Let's go back to our 3D. All right, that looks already pretty good. Okay, so let's talk about like these extensions at the bottom here. So pretty typically in one of these handrails, I'll go back to here. You've got the bottom termination and the top termination. And this, in this instance, is talking about a termination that goes back into the wall. So you can see here in the plan, it looks like this terminating back into the wall, not like a hook, not like a hockey stick end. So you can see that the handrail continues 250, so it goes for one more tread before flattening out and going for 300 mil and then turning back into the wall. So let's go back to our handrail, click on one of these, I'll click on this one, go edit type, and then we'll go back to our handrail, and then within here we'll take a look. So the extension at the bottom, is there an extension? I can say it's either to the wall, to the floor, or a post. Let's leave that for the moment, but let's say plus tread width, plus tread depth. I'll say okay, and then apply, and I'll move that across, and that's now come out. It's hard to see on this view, but it's actually come out one more tread width or tread depth. And then I'll go back to here, and then say, where are we? Plus one tread depth, yes, thank you. And then a length of extension, yes, 300 mil. So okay, 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 click OK. And you see now these pipes have come out. Let's go back to our section just to review what we've done there. So I'll make the section a bit bigger. So you'll see that if I do a detail line from here up, that's one more tread depth and then 300 mil out on that stair. Oh, sorry, on that handrail. Go back to our 3D view. And then finally, go back into here and to our handrail type. Okay, and then what's the extension? We can say turn it back into the wall. Cannot create the fillet. Well, let's just see what that looks like. Yeah, it did do it. Okay, yeah, okay, because it's only 50 mil and it's a 40 mil pipe. If I change this to a 30 mil pipe, it will do that. And I'm just going to do that. I'm just going to change this to 30 mil. Does that work? No, I'll leave that at 40. That's okay. All right. All right, and then you've got terminations beginning top. That will apply. No, that's fine. So you can see now how the handrail is turned back into the wall. But if we extend, we can make that bigger. So if I go back to my ground floor, you can see that that is turning back into the wall. But because of the handrail offset, it thinks that the wall is here when really the wall is still another 40 mil away because that offset. So let's just go back into our handrail and just clean that up. And you can see that this is quite a bit of time and just trial and error, just trying to make sure everything's right. The hand clearance is minus 45, it's 5 mil to there. So let's say it's minus. I'll change this offset from path back to 0. There we go. Okay, that's good. All right, so what we're after is that distance there. That's 30 mil. We need that to be more. Let's go back to here. So minus 90. That makes sense. 40 mil for the pipe plus 50 for the handrail. There we go. Okay, that's better. So now that's turning back into the wall, and I have to do the same here. So the offset from the path of the rail itself is 0 because the offset itself is built into the handrail. That's much better. So I go back to here, and you'll see those pipes terminate nicely into the wall. That's great. Okay, but we can change that around. So this is why you would need multiple types, because you can see this looks all good at the moment, but you'll have some projects where this one needs to be like a hockey stick turning down into the ground, and this one needs to go back into the wall. But they're different types of rails. So I'd need to have in here under top rail type, I would need to create 2. I'd create one that's 40 mil that is wall terminating, and then edit the type or duplicate the type and say this top handrail type is terminating into the floor. So let's just take a look at what that does look like. If I say into the floor, click OK, OK. Even here it kind of shows you what that's going to look like. But let's just take a look for ourselves. So it looks something like that. All right. But I'll go back because I prefer the wall. All right, so I go back to our handrail like so. And then we have our bottom termination, which is currently none. Okay, so there's a wood termination. So there's like a wood, essentially like a wood plate. Not saying that you're going to have that, but if this was a wood rail, you might have something like that. But that beginning, that termination profile can be anything you like. Personally, for your assignments, you're not going to need it. Then you have the top as well, the top extension. So let's get out of here, and I'll just come up to the top. Now, the top is still the same. It just ends flush with the stair itself. But if we want to clean that up, I'm going to go Edit Type, come back to here, the 40 mil handrail still, and then the top termination. So the top is going to be also into the wall, and its extension is going to be 300. Click Apply. Now this comes up, comes out 300 mil, then turns back into the wall, which when we look at the example is exactly what happens. Up, flush with the top of the riser, down across 300, terminates back into the wall. So back in plan, I'm just going to double check our width, which is 920. That's too narrow, so we need to increase this width by 80 mil. So I'm going to double click on the stair. We can edit this on the fly. And I can say 1180, like so. I'll be honest, I'd probably make that 1200 just to be safe. What I'll do first. Yep. And then what's the width between those two? 121. I'll make that 150. Yep. And I'm just going to extend that to be 1200 as well, just for argument's sake, and make sure that's 150 between them. Click OK, and the handrails automatically update. Now I've got 1020 between them, which is good. 20 mil for compliance checks as well. So that's good. That's now a compliant stair. That looks great. Now you're probably thinking, so if I go back to ground floor, I'm going to grab my walls, and I'm just going to grab like a generic 200 wall. And I'm going to go from ground floor all the way up to level 1 the whole way. And I'm just going to follow this around the stair, like a typical fire stair would. Okay, like so. Go back to my 3D, and it looks something like this currently. A quick disclaimer that in order to get the supports, what I've done is change my handrail setup slightly. So if I click on one of these handrails, I go edit type, and what I've done, and make note of this, is the top rail. I've chosen not to use the top rail because I can't pick a support for a top rail. So what I've done is I've got a handrail 1, so no top rail, just handrail 1. The type is the pipe wall mount, so I click on that, and this all just reflects exactly what we saw before. The key difference is, if I go back to here, in the top rail, I don't have the ability to choose a support system. I can do top extension, bottom extension, termination types, which is what we just went through before, but I don't have the ability to choose a support. So when I go into handrail 1 instead of the top rail, you'll see here I've basically I have mimicked everything that I just went through previously. The only difference is under supports, I have support metal circular fixture, which is the one we loaded in at a fixed distance of 1200, and the justification starts from the center outwards. So what that means is that these little support handrails here, these are great because they're parametric as well. So if this handrail needs to move out or in further, these automatically adjust. But you can see how they're placed at 1200 intervals. They start in the center of the handrail, which is here, and then there's 1200 out from there. Now, it may not always work. Take a look at this one here in the corner. That's pretty unrealistic. So the way we can manipulate these supports is I can just hold my mouse over the handrail, hit tab on the keyboard, so I then click on that support. I unpin the support, and then I just drag it around. So I might drag it to here. That's pretty realistic. And now I've made this wall semi-transparent, so we can see that looks much better now. Moving on to the stairs for our actual project, I'm in currently the working ground floor plan, and I'm just going to take note of some of these dimensions here before we go sketching this out. So we've got basically a meter clearance either side, that's excluding our plasterboard, and it's a tight U-shaped stair. So what I'm going to do is just come over here, and I'm just going to sketch that out with some reference planes. I'm purposely going to do it away from this drawing just because it's easier, and then move it into place. So I'm just going to do a couple of reference planes. Okay, and dimension those up. Excellent. And then what is the depth from start to end? So from here, 2460. Okay, cool. So our stairs look something like this. And I know that I'm going to have the same distance around here. Something like that. Okay, so I'm going to go up to architecture, stair, and I'm going to use this option to sketch the stair in the modified panel. So this is probably the easiest way to start with is we got our normal sketch palette here, but we have the ability to draw the boundary of the stair, the risers that define the stair, and also the stair path. I do want to make sure though, I'm just going to go back out of here quickly. I'm going to make sure they got my height set up. So from ground floor to level 1. Okay, perfect. All right, I just want to double check as well. Go into my section. 3150. Yep, just making sure I got all my levels correct. So go back to my working ground floor. Cool. Okay, so sketch the path. I'm going to start with the rises first, actually, and I'm just going to draw from there to there, there to there, and then I'm going to go from there to there, there to there, and then these here, I'm just going to click on them, and then the two different rises, and then go multiple, and then just move my hand down, and let's just go 250. And let's do something like that. And then we will have our boundary. So I'm going to click on boundary, and this will be a green line. And I'm just going to trace around the outside of these stairs like so. Okay, and then I don't need to do this part here because it's the riser, but I need to go around the middle part here. And then I need to take one more riser line and go from the central point of the stair and go like that. Now the last step I need to do is I still need some more risers, so I'm just going to double click. Let's go another one, 2 remaining. Okay, so I have 2 more risers remaining. So what I need to do is that's our maximum distance for our staircase. I just need to extend these lines down to here. And if I turn on thick lines, this is what it looks like, just so you can see. So the green lines denote the boundary of the stair, and the black lines denote the risers. Now I need to split this in 2 somehow. So I'm going to do something like this, and then take another riser and go from there to there, something like that. I'll delete that, take these 2 and go mirror from the center point, and then go like that. There we go. So 17 risers created, 0 remaining, and they're all compliant. Last thing is a stair path. So I click on that, and it's going to go from bottom to top. So I'm going to click once here, and then I'm just going to come up to around about there, find the middle point, do something like that, find the middle point, go up to there, and then I'm going to use my trim tool, and then trim extend the path. Okay, that's done. Next, click OK. Why can't I make the stairs? Okay, yep. Alright, that's because I've made the wrong type of stair, the monolithic stair, not the assembled stair. So I'm just going to try this. I'm going to just copy this. It's very frustrating you can't change the type of stair once you've committed to the sketch. So I'll get rid of that, everything goes. Change that to our actual stair type, which is this one, the one we started with. Go sketch, and let's just see if I can paste. So I went, I copied that first, I selected everything, went Control C, then went back into the sketch, went to the modify panel, and then came over to paste, and then go align to current view. There we go, nice, that saves us a bit of time. And then we'll say OK. There we go, that looks good. So let's go back to our 3D view. Nice, excellent, that's good. Yep, looks good. We're not going to have stringers, and you can see the stringers are a little bit cooked in the way that they're sort of conjoined, just in terms of their height. Yeah, we'll go without, because I reckon we'll just go straight to the plasterboard. I'll delete those. Okay, so we're going to end up with something that looks like this. Alright, excellent. So say OK. It's probably going to stick a handrail on it. It's going to cook the handrail. Yep, okay, it's got handrails. And I'm going to just delete those for now. And then I'm going to go back to our working floor plan. There's our stair. And I'm just going to click and drag this over to here. Rotate the stair 90 degrees. Excellent. And then just play the align game. So I'll align this to there. And then this, where's the back of the stair? To there. And there we go. They're fit into place. So let's take a look at this in 3D. So I'm going to click on the stair and go BX on my keyboard. And just take a look at that in position. Okay. Now it's too high. The stair you can see there has actually ended up being too high, but that's okay. So let's say that we want, let's click on the stair and go back into our edit stairs. Okay. And we'll go back into our sketch. So I'm going to go back and break this sketch up. So let's go to our working ground. Oops. Quit sketching. Click on the stair and then say edit sketch. Alright, so I'll click on this and let's just double check. 17 risers create, 0 remaining. So what happens if I get rid of that riser? And I'll bring this back to here. Okay. Stair path is invalid. Oh, okay, so that's because this path here, I need to connect this back to, I need to connect this back to here. Whoops, I'll go okay. And let's go to 3D. Yeah, much closer now. I think I need to get rid of one more because it's ending with a riser. So I want to turn that off. So end with riser, nope. Okay, that's better. That looks nice and clean now. That's ending at the same height as our finished floor level. And now I just need to clean up the floor so it meets the stair correctly. All right, I'll click OK. It looks better. Let's just clean up this. Okay, so this is our floor. I'll just go, yep, like that. All right, there we go. That looks good. And then I'll just go to my working ground floor. Let's just go to our section 1. That's cutting through the stair. And that's what our stair currently looks like. So with my section box selected, I'm just going to select the stair and click on edit stair. And then in the modify ribbon, click on the staircase and then go edit sketch. And what I've done is I've just gone around in 3D using the align tool and clicked on pick the surface of the wall. So say like here, I picked the surface of this plaster face and then aligned the green line to that. And I did that the same around the side, the nib of the wall, clicked on the end of the wall and then clicked on the green line to align that too, because we were dimensioning to the core, as in the stud, not to the actual plaster face. So I just wanted to make sure that that's nice and clean. So I'll go okay, and then let's get out of here. I'll go okay again. And then when I go back to that section, that looks, there's no gaps there now. You can see here there's no gaps. We can see all of these lines on the other side of the stair. That looks really clean. In fact, what we can do, I'm just going to go edit type. We'll go back to our monolithic, our timber type. So I'm going to go, yep, into our material. This is for our tread, for our riser. And I'm just going to quickly give that a cut pattern, just of a small diagonal crosshatch, like so, just so it stands out. So I'll go like that. And you can see that crosshatch is now showing in 3D. And that shows up where the cut line is as the stair comes around all the way up to the top floor. Now, a few other things that we should clean up while we're here. This is very finicky now. This is very, very finicky modeling. So turn off my thick lines. Click on the section box, and I'm just going to drag this back to being halfway through this riser, this run here. So let's take a look at this. So we've got our underfloor here. So walk into our sort of storage area that's underneath the staircase. That probably needs to be cleaned up and trimmed up a little bit too, but we'll wait till we get more details about that. You'll notice that there is this small gap in the difference between this, where the stair ends, and where the finished floor is. Reason for that, because the actual structural floor, which is the T&G flooring, the tongue and groove flooring, is sitting at level 1 at 0 millimeters off the offset. The timber flooring, the finish, is sitting 20 mil above that level. That's why you're getting this little nick right here. So I need to click on the stair. So the base offset is 0. The top offset is level 1 plus 20 mil. When I do that, you'll have this now where the stair and the floor finish flush, and that's all good. The next thing to look at is sort of how these two walls are joining, and then just taking some care and consideration into this. So the stud wall sits on this like so. You can see there's like a small gap here. And the reason for that is because I can have a base offset for this this wall. So I'm going to go edit type, and this is about just cleaning up some of our walls. And we'll do this as we go around the project. This is completely normal. So similar to what we did with our brick veneer wall, I'm actually just going to zoom into here, click on modify. I'm just going to click an unpadlock the base of this wall. I'll say, yep, okay, alright. So, which side can I drag? Can I drag this? Yeah, beautiful. So what I've just done there is just drag the plasterboard down to meet those two. And then what I can use the join tool. So in the modify panel, modify tab in the ribbon, I'm going to click on this button under the geometry ribbon, click on join and go one wall, second wall, and now that line disappears. So you got this nice consistent plasterboard finish. So it looks nice and clean. I'll drag this back. And we probably have to do a bit more work around here too. So this ceiling, for instance, when you walk up a stair, usually you can look all the way up to the top of the void. So I need to clean this ceiling up. What I'm going to do is just double click on this. This is great. If you should get used to aligning things and modeling in 3D, because it makes life a lot easier. So I'm editing the sketch of my ceiling. I'm going to go AL on my keyboard, click on this nib wall here, and then click on this line here to bring the ceiling back. Click OK, and now it looks something like that. So imagine when you're walking up this stair and you look up, you're going to see all the way to the top of the ceiling of the level 1, like so. Okay, but what I do need to do is bring this wall down, so I can go something like that. But I do need to clean this up a little bit as well, so it can get very finicky around here now. So I'm going to just bring that on top of there, but I need to flip this wall around. So because my plasterboard that I can extend like that, like the brick veneer, is on the opposite side. So what I'm going to do is click on the wall. I'm going to change in the properties window, instead of being drawn from the location line of the finish face exterior, I'm going to change this to wall center line, and then I'm just going to hit spacebar on the keyboard. Okay, so it's flicked that wall around, but what it means now is I can drag this down without any effect. Okay, so then what I can do is double click on this ceiling, AL, there we go, go OK, and now it looks something like that, much cleaner. Alright, and then this area around here, I just need to make sure that I draw that on the same path. So I'm using the align tool. Oops. I'm just hitting tab on my keyboard to find the surface that I want, which is that one there. Click on that and go OK. Whoops, that was definitely not the right line, was it? Oh, that's the finished flooring. I need this one, the tongue and groove. Let's do that again. Don't attach. Okay, there we go. So it looks something like that, and tongue and groove would be going through there. But to be honest, you would probably have two walls. It's very, very finicky modeling, but you'd probably have a wall here where the stair is, and then another wall that sits on top of that. In fact, you definitely would. So I might just drag that back up to there, and then I could just Control C and then go paste to the same place, and then just change this wall. So I'll drag this one down so I can just tell immediately the difference between them. Drag that down to there, and then drag this one down to here, and then use AL, align it to the underside of this floor, and it will look something like that. And then I just got to clean this up. There we go. I just want to make sure that in my level 1, how far is that drawn, that wall? Yeah, that's only that. Yeah, that's perfect. That looks good. Go back to here, and then go join 1, 2, and now that plasterboard's missing, and that construction detail is accurate. This is incredibly finicky drawing, and I'm not sure whether you'll be up to this sort of level of detail in your working drawings class. And if you're not, that's fine. Don't worry about that for now. When you get up to there, you'll know what to do. One last thing as well around this staircase, I'm just going to click on the ceiling and go edit boundary, and I'm just going to move this ceiling opening to be in line with the staircase itself, because I drew that a little bit far beyond. Yep. There we go. Much better. And so I've got quite a bit more cleanup to do over here. I'm going to drag this back the other way. Okay, so you can see that gap there as well. I need to fix that up. And this is very typical of what happens when you model in 3D. You lose track. I mean, it's very hard, especially these junctions in between floors. Like that looks much better now, that sort of balustrade wall. But that needs to be cleaned up. And it's very typical that this does happen. And you won't see it till you start doing stuff like this with section boxing in 3D. But again, it's just something to look out for, and some of the methodologies and workflows you can use to clean that up. The last thing I'm going to do is just do like a wall here that will end up being like a balustrade. So I'm going to go to our ground floor working. I'm going to just pick this wall here. I'm going to go CS, create similar, and I'm just going to draw along here like so. But I've purposely drawn it away from this wall because I'm going to then right click on the little grip on the left hand side and say disallow join. So when I drag this back to this wall, it doesn't end up joining to this wall. They're two separate walls, okay? Because then what we want to do is I'm going to create another section. So I'm going to go section marker, and I'm just going to go across there, double click on that, and then there's that wall there. I'm just going to drag that down slightly. Okay, so this is just a working section. I'm going to then go edit profile. So I've clicked on the wall, the modify panel. I've then clicked on edit profile, and you get this that appears. And I'm just going to drag this down like so. Now, if it won't let me, that's fine. I'll just draw a line like that. I'll go from there down to there. And what I want to double check is just the height. So from that tread up to there is 800. We'll make it 900. And I'll do it again here. Draw up 900. And then I'll just make sure I move this line to meet that. Yep, nice. Okay, so then what I'll do is I'll get rid of these two. I'll delete that. And then I'll go trim. So it looks like that. The red dash line you're seeing is sort of like the original location of the wall, and the magenta line is what our new wall is going to look like. Okay, so what I'll do now is I'll go okay. Looks like nothing's really happened, but if I go back to 3D, that's what we've got, something like that. So when I drag this out, and I go back the other way, in our living room, so you walk through the front door, there's our staircase. I'll drag this the other way. It looks something like this. The last thing to do to the staircase is to add a handrail to it. Now, in terms of the compliancy of the handrail and its design, I'll leave that for your working drawings class. But the process in hosting a handrail and then editing one is like this. So I'm going to go back to railing and place a railing on a stair or a ramp. So I'll just click the stair. Okay, you're going to get the railing on both the inner and the interior and exterior. So I'm going to delete the interior one. We're just going to leave an exterior handrail like this. And then what I'll do is I'm going to click on that, and let's change it to one of the pipe types, the 900mm pipe, which is the one we were utilizing before. But I'm going to just duplicate this, and I am just going to call this duplicate, and I'll say internal stair handrail for our residential, because you've got now in this Revit file those compliant commercial fire escape handrails. So keep that in your file and we'll work through this. So this one here, handrail 1, remember we're not using a top rail, we're just using the handrail. So it's pipe wall mount. Again, we're going to need to duplicate this because we want this to appear slightly differently. So I'm going to duplicate this, and I'm going to call it just the same thing again. What did I call the other one just quickly? Internal stair handrail. Okay, so let's do that. We'll rename, we'll duplicate it. Okay, so now we can play around with this. So fill it, yep, all the rest of it. Now the extension. So residential, we'll get rid of these. So no beginning extension. no plus extra distance, and the length of the extension will be 0. And then likewise with the bottom, the top as well. So no end termination style, and the length will be 0 as well. So let's just play with that quickly, and I'll say OK, and that's what we get, something that looks like this. So you see that down here at the bottom, that handrail doesn't extend beyond the bottom of the stair. All right, next up, let's go back to that handrail again. I'll move this across so it looks like this, so we can keep an eye on that handrail. Okay, and then let's take a look at some other things. So internal stair handrail, let's change the support distance to say 800. So you'll see there's more supports periodically. And the height, let's go from 1000, let's make it 950 or not. Yeah, let's say 950. Okay, all right, that looks good. So we'll click OK. Now, next thing to do is let's just double check that it's sitting correctly. So you can see it's sitting off of the edge of the wall. So the offset from path, I'll change back to 0. Now that's stuck to the wall, that's good. But the handrail is slightly higher than our nib wall here, and it's on a weird angle. I think our nib wall was drawn on an incorrect angle. So I'm going to go back to that little section that we drew before, and then click on the wall and then edit profile. And I'll just fix this up. There we go. And then I'm just going to move that line so it's higher than the handrail. I might move it up 200 mil. So it's like that. Click OK. Go back to our 3D. And now it looks something like that. That's better. All right, so the handrail is probably not going to do something like this. I mean, it could. There's no reason why you couldn't have a handrail that ends up like that, where it comes around the side and then if I just draw this back, that does something like this, that comes up the stair, comes around the side, follows up on an angle around the U-turn, and then comes back up to the top of the stair here. No reason why it couldn't do that. But what I'm going to do, that's annoying me. There we go. But what I'm going to do is just edit this sketch path, just so you can see what you can do with sketch path editing with Rails. So I'm going to move this back, bring that down. I'll move this in as well. You can see how powerful the sketch tool is. The section blocks tool is. So I'll click on the handrail, and then I'm going to click on edit path. And what happens is you get this U path like this. And there's the arrow that denotes from the the sketch origin from bottom to top. But what you can do is you can click on these and delete them, extend them, draw them, do whatever you want with them. So I could take those two and delete them, and then click OK. And now you've got just this handrail component here, like so. And if I move that back like this, you got something that looks like this. All right, but this isn't quite right either, because you probably wouldn't have the handrail continuing on all the way up to here. You might want the handrail to end at the top of this riser. So I can double click on that handrail, and I can use my align tool, and then grab the front of this stair, and then click that point on the end of the line, and it drags that line back like so. And I could even do the same thing here. I could say, well, I want the handrail to start, say there, and it's going to be like that. Now when I click OK, you can see that handrail goes for that distance there. I need to fix that wall again for some reason. But it gives you a bit of an idea of what's possible. But see, you've got now one support in the middle. So I might just change that back. I'm going to leave this base in the same location. Yeah, that's probably better. And now you've got 3 supports. Now we're just using a pipe, or like the 30mm circular diameter pipe, but you could use whatever profile you want. We could change that to a go into here, and then the internal handrail. At the moment it's just a circular pipe, but we could use anything we like. You might want to use what's this, rectangular handrail. 50 by 50 is square, not rectangular, but okay. Let's see. Okay, and you can see now that's updated. So you could create your own profile family, your own railing profile. And it's the same process of how we created like a gutter profile, essentially. It's a 2D sketch that ends up being loaded in, and then you can pick it. I'm going to stick with just the 30mm handrail, circular. Like so. And then to add the handrail to the other side of the stair, I'll drag this up first and then move this over here. Okay, and then I'll go through the same process again. So essentially I stick that same handrail on the other side. I'm going to pick the internal stair handrail from the type selector, click on the stair. I'm still going to get two, one on the inside, one on the exterior. I'll delete the one on the interior. The one on the exterior, I just need to edit the path. So I'll get rid of these two sides. And I can use my line tool again, and I'll say I won't start my handrail until, say, that point there. Alright, that looks good. Say okay. No, I'd probably start it beyond, further back from there. Let's say, what have we got to align to? That point. I can just go to a top view plan level 1. That's better. I'll sketch it from here. There we go. Go back to our 3D. Alright. Alright, that's better. Now, this end here, I just need to double check what's going on there. So, edit type, internal handrail. That's okay. And to just end, so at the moment it comes up the stair and then flattens off at the top. And so what I'm going to do is go edit path, and I'm just going to use my align tool to the top of the stair, the last tread, click there, and then click the end of that line. So I've shortened down the distance of the run of the rail, and you'll see now that ends like so. Now, this could be non-compliant. I can't remember exactly for residential, but these are the different techniques and methods you can use to adjust these handrails as you go along. The other thing I'll do as well is just make sure that offset from path is at 0, like so. Okay. And let's just go back to our section. Oops, our actual proper section. Yep, and now we can see that handrail behind that wall there, following with the stair. Topography in Revit can be found under the Massing and Site tab, and then within this Massing and Site tab, the ribbon's broken up by the first component, having to do with conceptual masses, and then modeling by face. This is more for conceptual modeling and for importing external geometry or complex geometry into Revit. The next component is the model site ribbon, which is to do with creating topography itself, adding site components, parking components, and building pads. Some of these are grayed out because we don't actually have a surface yet. Then you have the ability to modify the surface, whether it's splitting the faces, merging faces, sub-regions within your property, property lines, graded regions, and then labeling your contours as well. So there's quite a few different methodologies that and workflows that firms and projects will use in terms of modeling site, whether it's brought in from an external resource, whether it's brought in directly from different files, whether it's modeled internally. It varies greatly. So I'm going to show you just a few different methods and what applies to this assignment. So under topography, I'm going to click on this, and what happens is straight away you've got 3 different methods, or a few different methods to actually create topography. The first one is to place points manually. And so what happens there is, looking in the green options bar, I have an elevation, which at the moment's at 0, and then an absolute elevation, which at the moment is the only thing I can pick from. And I'm currently in the site tab, in the site drawing. And if I just go 1, 2, 3, 4, and then click OK, nothing happens. And it also doesn't happen because 2 reasons. 1, our view is not down far enough, and 3, we may not have topography shown in this view anyway. If you go to the 3D view, and I'll turn off the section box, you're going to find topography somewhere all the way down here at the 0 level. Because keep in mind that our property is sitting at like 57 meters odd above sea level. So this is currently sitting at 0. Those 4 points were just random points anywhere in space. If I go to the top view, you can see it's not straight at all. There's no snaps or anything. And it's just sitting down there, all the way down there. Now, I'm going to go back to our site plan, and we haven't made a view template yet for our site plan, and that's intentional. But what I am going to do is change the view range in the properties from from the top view being the associated level, which is the ground floor, and then the offset above being 100 meters, and then the associated cuts also at 100 meters. This is why we can see the roof completely. I'm going to change the bottom to unlimited and unlimited for view depth. So that way we see the garage, but importantly we see this site all the way down here. So I can click on edit surface, and you can see now those points that I just clicked on randomly, and then the polylines that string it together. So I can change these points after the fact, or I can make new points and put in a number at that time too. So if I click on place a point and I say, actually, I want this to be at, let's say 50. I click there, click OK, go back to here. Oops, what I do need to do, I'll just double click on that. That point, sorry, 5,000. Okay, click OK. You get something like this, like a pyramid shape. So these 4 points are at 0 meters, and then this pyramid here is at 5 meters, and so it creates contour lines for you like that. So if I get rid of that point, I can just delete it. I can go back to my site plan, and let's do something a bit different. So these 2 points here, I can select them, and I can change the elevation of points after the fact. So let's say that's at 5 meters, 5,000. You'll get something that looks like this now, just like a sloping site, and that's why you've got those contour lines, probably at 1 meter intervals. So it looks something like that. If I go to an elevation, like the right view, you can see how that site looks. All right, and if I go back to my site plan, I can draw contours as well. So I can say, all right, that was at 5 meters. Those 2 points are at 5, but I can say this one is at 4 meters, and I can just start clicking away. So I can go from here, and you'll see the contour lines change depending on how I select. And then the next one might be at 3 meters. And I'll do something like this. I'll make it very close to the other one. So the closer they are, the sharper the fall in land. And then 2 meters. So these are further away, but I'll make them closer here. So this area right here will be a very steep fall. And then 1 meter. Like so. And even 500 mil. Cool. And I'll say okay. Doesn't look like too much has happened, but go to the 3D and you'll see how that land looks now. So there's like our top area, and because these contour lines are really close, you can see that it's got like a really steep fall. Like that. Now, topography traditionally in Revit doesn't look that great. It's just a simple mesh model. But if I click on that and use my section box tool, so BX, I've got my section box around it. Watch what happens when I cut into it. It actually shows you topography underneath, like land. That's only if I use the section box, and it's infinite no matter how far down it goes. So the reason why it's not showing on this side is because I haven't cut back into the land. But if I drag this back into the section box, the section box back into it, you can see these two sides now have like thickness given to it. This side does not because I haven't cut into it, so I can do so like that. And now I've got like thicknesses on 3 of the 4 sides. And that starts to show a little bit more about that topography and that fall in the land. All right, so I'll get rid of the section box. Land goes back to being like that. Still miles away from our project, but we'll fix that up a bit later. Okay, so I'll go back into edit surface. Now, come back to here. Now you can always edit this after the fact. I can drag these around, I can move them. Generally, it helps with, if you're drawing a site from scratch, it helps to have reference planes. You'll see here, if I draw like, if I've got like a dead straight site or something, even if it's on an angle like that, these points will snap over those intersections. It's really like the one way that I can snap to certain points in geometry. Or certain places in space. It won't even pick up, it will pick up on some geometry of the house, but usually you're not snapping topography to a architectural object or to a building. It's usually to land elements. Okay, so that's that. So next up, let's just take a quick look how this looks in section. So if I just draw a quick section, just going through this land like so, I'll make sure you can see the whole land. Go to that section, and you'll see you actually get the topography with that fall, with the landfall, and you get the earth hatch as well. And that's just controlled by how much you want to see in your view crop or in your crop region. All right, so the next methodology to create topography, I deleted that site, just go back to topography, is you've got create from imports. You can either create from import instances or specify points from a file. The select import instances I'll go through shortly, but the points, if I click on that, it's going to open up my file, my Windows Explorer, and I can pick from either a TXT text file or a CSV file, export from like Excel or something like that. And so I haven't got an example to show you, but just know it is possible. And I'd highly encourage you, whenever you're working on a real life project and you've engaged a surveyor, even if you haven't personally done it, but you're a part of a project that's engaged a surveyor, the quickest way to make highly accurate topography is to ask your surveyor for the points or the contours in CSV file format. So what it will look like is if you open it up, it will just look like a table with just thousands of lines of text, and there'll be X, Y, Z coordinates for each of those points. You import that into Revit. Revit reads those points and essentially lays them out for you in the coordinates that they were originally taken on site and creates a topography for you. It saves you a lot of time, because even if we have a survey file and we have to remodel the topography over the top, it is just very time consuming. This would save you a heck of a lot of time, especially on bigger sites, like say like a school or like a football oval or like a community center or something like that. Even like new estates, anything with vast swaths of land, topography can take a very long time to model. All right, so I'm going to get out of there. And what we're going to do is just look at the reference documents. So I'm not going to go through verbatim, what everything is in this drawing in a survey file and everything that has to go onto a site plan. What I'm worried about and what I'm teaching you is the workflow of how to get from here into Revit. Actually how to document it. Setbacks, dimensions, site features, that's all for working drawings. So we're taking this site. This is the site that we're using in Forest Hill. This house here, and Jackson's done a lot of work for you in terms of CAD files. But this is the site establishment survey, so giving us our boundary, and then this is our site features and level survey. The survey is pretty good. It's got almost everything we need. The only thing it doesn't have is it has a temporary benchmark which gives us our height datum, but no coordinates. I really wish there was coordinates here. That's another thing to make sure you ask for, is not just a reference height, but ask for reference coordinates somewhere where you can establish the site. So, because what will happen is when we bring this in, it will sit in Revit correctly, or all the rest of it, but it's actually not going to be geolocated. Our model is going to be located at 0, 0, and if we were using like a shared coordinate system, or if we had like, again, a school project with multiple campuses, you need to have shared coordinates established so you can have these buildings correctly located on a site. And even for bigger projects, think about like rail projects in the commercial world where you've got like different stations. They all have to be aligned to the same rail alignment, which means they've all got to be reading the same coordinate system. So just keep that in mind. When you're working with Surveyor, ask for the points in CSV file and ask with the temporary benchmark, your TBM, to include not just the height reference, but also a coordinate position as well, northing and easting. So let's open up CAD. So the two CAD files that are provided to you, you've got the original survey in CAD with the existing house, and we're taking it as a blank slate. So the house has been demolished, everything on the site's been demolished, and then we've got a post-demo site plan or survey model, survey drawing that looks like this. Now, this model has been extensively cleaned up. That's probably one of the biggest things that you have to remember is when you get survey files, they are a mess. There's usually 50 to hundreds of different layers in there that all look the same. So in here, you'll notice in the properties window, the layers window, you've got one for the buildings. You've got site contours on a separate layer, dimensions, landscape. This is incredibly clean. This would have taken a while to do, but this is already done for you. But there is still more to do to clean up in here to then bring into Revit. So we're going to go back and forward. So this is actually a really good workflow to go through. So this file here is the one we're going to bring into Revit first. So I'm going to go back to Revit, open that up, go to my site plan, and I'm going to go to my Insert tab, and then I'm going to click on Link CAD. Now that's another big thing to remember, is that when you're working with CAD files or external models, whether it's a Link CAD 2D drawing like this, or whether you were trying to bring in, say, like a Rhino model, never import, always link. That's a key one. Never import, always link. If you import all those layers, all those line styles, all that geometry natively into the file. It just slows down the model. Plus, it doesn't allow you to update the model as easily. With this Link CAD system, we'll go through it shortly, but you can make updates to your drawing and just refresh the link in Revit, and it's completely seamless. So I'm going to pick my post-demo drawing. It's a DWG file. It's not for the current view only. If I click that, it means it would only import into the site view. I want to see this in basically all the views because it's a good reference, and then we'll just hide it in whichever view we prefer. The colors and layers, you can preserve them, but I'm going to make them black and white because it's going to help us later on. The layers, I'm just going to say give me all the layers currently inside of the file. Actually, no, I'm going to say visible. So whatever is visible inside of the AutoCAD file, what layers, it's going to show here as well. And that's important for later. Next is the import units. You can click on auto detect. Revit's pretty good at doing that, but I usually like to say, no, it is definitely millimeters or feet or inches or meters or whatever. This is important as well because traditionally native survey files are done in meters, not in millimeters. So keep that in mind. Underneath of that is the button to correct lines that are slightly off axis. That is not the case here. Survey files, land features, land level and features are traditionally never perfect right angles, so you don't want Revit to automatically correct those lines. Next is positioning. So if we had, this is an entirely different class within itself, model positioning coordinates, and it's probably one of the most complex components of Revit is its shared coordinate system. But I'm just going to choose manual center for now. Place at the ground floor, sure, and orient to view. I'm going to untick that. So I'll say okay, and it looks like nothing's really happened, but there's that drawing. It's just sort of being floated around in space. And I'm just going to move this off to the side like that. So that's now imported. Okay, and immediately you can see this is not quite right yet. There's still some things we need to edit. But what we need to do is we need to establish our boundary and our siting relevant to the building. So I'm going to make sure that I hide a few things. So I'm going to go to my gutter. I'm going to temporarily hide that. My roof, temporary hide that. Even my fascia board, temporary hide that. Because I want the side of this brick wall. Okay, so let's go into here. So, okay, what I'm going to do is I'm going to use my align tool. So this is pretty crude to begin with, but it will work. So I'm going to click on the CAD file, and this is because the CAD's in black and white. If I left it in colors, it would look like the same colors that are in inside of AutoCAD like this. So I know that the blue line is my title boundary. In this instance, but inside of Revit, because it's all black lines, I don't know which one's the title boundary. So again, it really helps when your CAD files are clean like this. I can't thank Jackson enough for cleaning this. But if I click on the site drawing, I can click on query, and what I can do is zoom right in, and you see these two lines that are next to each other on the title boundary. I don't know which one is the title. So is it the inner one or the outer one? So I'll click on the inner one, and that is good. So it reports the import instance query. The layer is the title layer, the title boundary. So that's great. So I know that's the line I need to align to, the bottom one. So I'm going to go AL for align. Just click on the boundary line of my garage, and then zoom in, click on that inner line like that. Whoops. I can't. Let me just, sorry, I just need to rotate that first. I'll just rotate this 90 degrees before I then align. Yep, that's it. So I'll do that now. I'll do that again. There we go. All right, so it looks like that currently. And then we need to work out our offset, our boundary. So first things first, I'm just gonna move the site to the left 150 mil just to give us a bit of breathing room for res code. So I'll go 150. Okay, so our site boundary and our garage are 150 mil off the boundary, give or take, because the site boundary is not completely straight, nor should it be. All right, and then we need to work off an offset back here. So I'm just going to use a reference plane roughly, okay, and type in 7,300. That's our offset. I'm just going to draw somewhere around here. Use tab to somewhere around there. So I know that my living room is going to be somewhere around this line here. Now I'm not going to use the align tool because that will twist the land, and that's not quite true. But I'm just going to go move and move this site, move the reference plane, and the reference plane is going to meet this corner of the house, like so. All right, so that's correctly sited. So when I go to my 3D, it looks something like this. Bit of a start. There's still a lot more work to do, but that's a start. I'm just going to change my scale. Yep. Okay, so that's how our house will be sited. Remember, this is at ground floor, so this is not giving us a true representation of height. All right, so in my site plan, that looks okay for now. So let's create some topography. So what I can do is going back to the topography, go massing and site, top of surface, and then click on import from, create from import. So I click on that and I say select import instance. So then I click on the CAD drawing, and you'll see now all the layers come up for the CAD drawing. This is why, again, it is so critical that the CAD drawing is clean, really, really clean. Because what I'm going to do is say check none, and I just want the contour lines, and say okay. And you can see now it's found all the points on the contour line, and I can just click OK, and now it's created that topography. So when I go back to 3D, you'll see that topography is being created. All right, it's not perfect, but it's a big start. It's done a lot of the work for us. Now, this is why usually import from points is like the CSV file. So if I go topography, create from, specify from a points file, that is still the quickest way, because the time to take to clean up a CAD file can be pretty long, and you could just ask your surveyor to just give me the points file. That's usually the quickest method. But nonetheless, this is still very, very helpful because the CAD file is clean and because those contour lines are on their own layer. If this line or this line was accidentally on the contours layer, then this would look very different, wouldn't look very clean at all. Now, the other thing to consider is that even though it's made the contour lines, notice that the side is flat. And that's because if I go to the CAD file like this, and I try and might freak out. Oh, that really did freak out. You can see the CAD file is indeed flat. There's no height given to it. Even though, if I go back to my top view, even though here you can see that there is a height datum given for each of these lines, each of these contour lines. Now, that's fine because graphically it looks really clean. The model's all cleaned up. But usually when you get surveyor models, it's not uncommon that the surveyor CAD file is actually three-dimensional, and if you were to go into like a side view, you would notice that those lines are actually not sitting all at the 0 point in the Z direction. They're all actually at the different levels. So that's fine. We just have to change this around out manually within Revit. So again, if I go back to our site plan, the other way that we could, I'm just going to hide this site quickly, like so. The other way that we create this site is by just going topography, and instead of creating from the instance like we did before, picking the layer, we can still create from point and then just manually draw this. So we can say, for instance, what's this number? 131.6. So I can type in 131,600 because that's 131 meters in millimeters. And I can just click and then just click away at each of these points periodically as I like, and just follow that contour around, and then type in the next one. So this one's 131.8. Say enter, then click on this point, and you can see how the topography is growing as I do that. And it's up to me how often I want to click on those points. And then when I'm done, I'd say okay, and then I go back to here, and I'll just hide that. The topography is going to be way up here because our site needs to be relocated, and you can see the fall on that little piece of land right there. Now that's another way to do it too, and that's completely fine. But what I am going to do is a bit of a hybrid. So we've already got the points that have been created for us. I'll go edit surface. Whoops. Click on that. So edit surface. All the points are already created. I just need to now reference those points, select them, and give them the right height reference. Now, this is going to look weird because this is going to end up miles above our project because the levels that we created for our project were incorrect, and we need to move our levels after we're done. So I'm going to go back to the site plan and take these ones here. These are 130.16. So I'll select these points. I can hold down Control to select more. And then up here in the elevation, I just change that to 131,600. Click Enter, and they're now moved. So if I say OK, this is going to look pretty weird. But you're going to get something that looks like this because these points have been moved, but all these are back at the original position. So it's fine, but just notice that that will happen until your points are cleaned up. So I go back to my site plan, and I'll continue on. So these ones here, these are 131,400. These ones here, 131,800. What are these ones? 132. $131.8. Okay, so you can see there's points under the house. Don't forget that. So you need to follow those. That's our 131.8. All right, and then what's this one? 131.6. You see there's quite a few points under there. So let's take a look what that looks like in 3D. Should be getting a bit more shape. Yep, so you can see this land's starting to get more shape. I just need to fix up the front down here, which I'll do now. So I fixed up all the points, but you'll notice there's one, it still looks like this. And I just want to give you guys some reference because this may happen to you. All this is that there is still one more point down here that I need to fix up. And that one is sitting just at 131. Oh, there was another one. That one's at 131.2. There we go. And now our site has moved up here. That looks all nice and clean. I can go back to my site plan and we can add more points after the fact too. So we only have contours back to here. Unfortunately, we don't know what these two last points are here. 131.4. It's on its way down back to the back of the property. That's 131.4. So, and that's got a contour. So I'm just going to place two more points, and I'm going to call them 131, I don't know, 2, just as an example. And I'll place one there. Oops, why can't I do that? 131.2. That should be fine outside the surface boundary. Oh, okay. Where is my surface boundary? I'll just go to my 3D. Click on my top view. Oops, I think what I need to do is I need to drag this. That's it. I'll just drag these ones further back. That's what I need to do. The topography, once created, is not going to follow the boundary completely. You can see here that it's beyond the boundary on the right-hand side. It moves further out at the front of the property, the front boundary. It sort of comes out and bleeds over the driveway or into the street, and then oversteps the boundary again. That's fine because ultimately this topography is a true reflection of the points taken by the surveyor, and that accuracy is much more important than just how it appears in 2D. We'll clean it all up anyway, so it gives a proper clean representation. The next thing I need to do is I need to move the model. So you'll notice that because the heights were taken, the site that we're using is of a much higher site than the heights that we did at the start of the project. We need to move those levels in the project. So at the moment we're sitting at like 54 meters above sea level or something like that. But up here we're at like 130 something. So I'm going to go to one of our elevations, and I'm going to go one where I can see the building preferably. Actually, it doesn't even matter because I just need the levels. So I'm going to click on each of the individual levels, and I'm going to move them so they're up sitting at the correct height for our site. So the correct height for our site is going to be somewhere around the 131.8 meter mark. So just take 131.8 minus this number here where our current ground floor is. Select the levels. I can't stress that enough. You're not selecting any geometry whatsoever, just these 4 levels, and you're going to move the ground floor up, and in this case be 77,150. That will take a second because that's a lot of information to move, but you'll see now that sits on the site perfectly in this elevation. If we go to our elevation sheets, you're going to notice they're going to look really cooked because all the drawings have moved up dramatically. So I need to double click into each of these views, go to our crop window, and just drag the crop window right back to the top. Keep going. Something like that for now. And then uncrop the view like that, and then clean up the drawing and move it back into the right position on the sheet. Just keep that in mind. It will only affect the elevations and sections, not the plans. The plans will be fine. If I go to GAs, the only thing you will notice is you're going to see the survey file and the topography. But this is why we have view templates, you know. So again, if I go to our ground floor plan, we can see all of the site. I'm going to go into the architectural view template, and then I'm going to come over to here where it says override imports. Click on that, and then go over to my imported categories, and you can see here here's that DWG file. I can just untick that. It's going to turn off all of the layers as well. Click OK. Click OK. Hides it from this view, and because it's the same view template, voila, hides it from the level 1 view as well. And when we go to those sheets, they're going to look much cleaner. There we are there. We don't see the topography in the floor plans either, because in those architectural plan view templates, topography is switched to off by default anyway. All right, now in the site plan, we've got a little bit more to do. We want to rotate this so it's in true north, and we can see the north arrow is actually pointing basically 180 degrees the other direction, so we need to fix that up, and then clean up the CAD drawing itself, and then work on a view template for the site plan. So to rotate true north, I'm going to go to the Manage tab and then under the Manage tab, you've got about halfway through, midway, you've got this ribbon called Project Location. Again, just these 3 buttons is probably a 3-hour course within itself. So I'm not going to go through anything that isn't relevant and confuse you. I'm just going to go through what is relevant here. So I'm going to change this view currently. It's currently in the properties palette. The orientation of the view is Project North. I'm going to change it to True North. I'll explain the difference in a second. Then I'm going to go to Position and then click on Rotate True North, and I get something that looks like this where I can rotate it. Notice it's rotating from basically the origin of Revit, from the project base point. I'm going to hit spacebar, and that means I can move the center point of rotation, and I'm just going to move it to the end of this arrow. So I click there, and then I click the other side of the arrow, and then I just rotate this so it's straight up the page like that. All right. So then what happens is you'll see the project now looks like this. So it's it looks a little bit funky, but the most important thing is that this arrow here is directly straight up the page. Everything else can be on an angle because this is a true north view. It should be. So this is how our site plan looks from true north. But if I go into my ground floor plan, everything still looks normal. Okay, so I'll go back to my site plan. The other thing I'm going to do is then click on this survey point or project base point. Yep. Oops. I'm going to click on the project base point here, which is this circle, and I'm going to, I want to paperclip that. Where are we? Okay, and then to relocate the project, so you can see because I've rotated the entire view, the project base point, which is this circle here, and the triangle, which is the survey point, they're now in different locations. The survey point is at 0, 0, 0, but the project base point is not. It's sitting at a different location. So I'm going to go back into my Manage tab, Project Location, Position, Relocate Project. I'm going to click on the center of that project base point, which is there. Zoom out, and then click on the center of the survey point. Okay, and now that sits it back into position. So it basically moves the whole project back to 0. All right, so if I click on that project base point, it's 0, 0, 0. Be sure to watch that a few times just to make sure you've got that right. In fact, I'll go back just to clean that up. What I'll do is I'll even isolate these two objects. So I've selected the project base point, the circle with the cross, and the survey point, which is the triangle with the plus. And I'll go HI to isolate. I'm just going to click on Position, Relocate Project. It doesn't matter that things are hidden. It's going to move it anyway. I'm going to go from this point here to this point here. Click that and then unhide everything, and everything's now moved. That might be a better way to do it. Just isolate the two objects you need, move it, and then we're done. Now, really playing with the project base point and the survey point is some pretty advanced Revit stuff there. You can easily cook models and corrupt files by playing with that too often. So I'm going to immediately go VG on my keyboard, and we'll go down to Site, okay, and then press the little plus button. And then in here, you've got the survey point and the project base point. I'm going to untick project base point and survey point, click OK. Those two items disappear. I never want to see them again. We don't want to actually see them again. All right, so now our true north is set up, and this is the difference. So true north is currently like this. North is directly up the sheet, and then if I click in here in orientation and click on project north, flips the project around, and this is the same view in which that we've been doing our floor plans. So our floor plans here, you'll notice that they are in project north. It's grayed out here in the properties window because it's set in the view template. So if I go into here, view template, origin, project north, and included in the view template, yes I do. So that's why that's grayed out. I'll go back to the site plan, and the last thing I'll do is we'll edit the CAD drawing and then load it back in, and I'll show you how to edit that. So you can edit certain items in here. So let's take, for instance, I click on the drawing and I want to hide, I want to see the roof line. This black hatch is not really appearing quite nicely for my liking. So I click on the survey drawing, and then I click on query, and let's say I just click on that hatch. I click on the hatch and it says the layer is site-other. I can then say hide in view, but then it hides everything else because those layers are not quite set up correctly inside of CAD, and that's fine. So my two options are I can go back into CAD, and the quickest way I'm going to solve this is I'm just going to select these hatches and just delete them. I don't need them. Delete and delete. So it looks something like that now. I then just go save. So I've just saved this file. I'll go back into Revit, and then I'm going to go up to Manage, and then I'm going to come over to here under Manage Project and click on Manage Links. And when I do that, these are our linked files, whether it's a Revit file, IFC file, point clouds, etc., but also DWG. So then there's our site file. That's our survey file, and I just say reload. So it reloads that. Nothing looks like it's updated, but once I hit OK, you can see now that hatching has been removed from the site plan. This goes on now with the rest of this stuff. So it depends on what you want to have drawn versus what you want to have imported. So another good example would be these title boundaries here. We probably would like to tag a lot of this ourselves. Same with even the the numbers of our neighboring properties. Everything's drawn to be in landscape when our site plan is going to be actually the other way around. So if I turn that back to true north, Okay, we want this to read probably a bit clearer for us when the view is in this area. So I would probably go into CAD and I would clean this up a little bit more. So I might make another layer and put all of the annotation on that layer, like an annotation layer that I can then control. Same with the title boundary. That's a little bit cleaner because that's on its own layer. So if I go back into Revit, I'm going to go. That's my topography. So I'm just going to hide that. I'm going to click on the CAD file, go query, zoom right in, click on that. That's our sight line. So I don't want that one. It's actually this one. Title. I can say hide in view. So it hides that one line. That kind of works, but it's actually hidden some of these other lines here. So I can tell that in that CAD file, that's not completely clean. The title is picking up not just our site, but some of the other sites too. So, oh no, that was right. Maybe I'm just missing those lines in general. But anyway, that's how we go back and forth. So you can either delete them straight up in CAD, but I would be a little bit more smart. I'd be a bit smarter about that and put them on like respective layers and delete those hatches. And let's just say I'll create a new layer. There is one for text, but it's, yeah, so there's a few things that come off there. So I can edit that, some of the text. So I could do that within Revit. I can go back to the file, click on query, click on one of these text components. Let's say it's that. That's the site dash text. I can say hide and view, and it hides all that text, which is pretty good. And I could leave that. Or, so what I'm trying to get at is I have layer controls within Revit, but for more finite things like moving certain layers to certain objects to new layers, or to create new layers, I have to do that inside of AutoCAD. And personally, it's just my personal preference. I prefer to control everything from CAD and then just bring into Revit. So in this regard here, I'd say, all right, well, I'll turn off the text, but then let's say this text around the house. So I'll click on these because I'll probably rewrite this with text inside of Revit. It will end up looking a lot clearer, printing a lot cleaner. So let's just say that there. I'll create a new layer. Site. Annotation. And I'll move all of these to site annotation and they turn off. Yep, no worries. I'll hit save. Go back into Revit. We'll go manage links. Go to CAD format. Click on the Revit on the CAD file. Reload. Click OK. Oops, too far. I froze the layer. Anyway, that would, and then what will happen there, I did something wrong in CAD, but it would just hide those layers. I must have selected more objects. That's personally the way that I like to control them. As it turns out, I wasn't hiding the layer. What was happening is that, and you may find this too, when I was reloading the CAD file back into my Revit file, it was actually moving it back to another existing location. This may happen from time to time. It happens a lot when the file, when this survey drawing, this CAD drawing is not actually geolocated. It's just sitting somewhere in space. So if I go to my Revit file, you can see the 0 point is over here. So if I go like line 0, 0, 0, it's only from here. If this survey file was actually geolocated, it would be like, 50 kilometers away from this point in the middle of no man's land. And then the model would actually, the CAD drawing that is, would actually be geolocated, and we wouldn't have to do all this sort of rotating and moving and aligning and all the rest of it. So it is a bit of a side effect of that issue. However, it's one that you may experience in your time. So it's actually a good thing that it's happened, because I'll show you what I would do in this scenario. So I'm actually going to just delete this, and I'm going to create a new one. So I'm going to go manage links. I'm going to go add a link. And by the way, this is a little bit different. So instead of going insert link CAD, what I'm doing is going basically manage links and importing it this way. So go to CAD formats and add CAD format. Click on that CAD file, and I'm going to change this up now, because when we've now done with what we needed to do, I'm going to import it just for this view only. I don't want to see this in any other view. It will just save us a bit of time. Positioning is still going to be, say, auto center to center, black and white, only the visible layers in millimeters. Looks good. That's loaded. Click OK. And there's our drawing there, but it's obviously off on the wrong angle. So I'm just going to click on that. I'm just going to click on this, go rotate, and just rotate that 90 degrees. Okay, and you can see we're already pretty close to where we need to be again. I'm just going to purposely just drag this out and go through the same process as before. So hide my gutter, hide my roof, hide my fascia board, align that. Like that. And then, oops, that line. I need to go another reference plane, 7.3 from this line here. Hit tab to get that corner, and then move the CAD file, move this reference plane down to there. Oops, I'm just going to need to realign that brick wall. So brick wall, there we go. And then I'll just move this over 150. Now I'm going to, yep, that looks good. So I'm going to click on the CAD drawing and I'm going to pin it this time. So click on the pin icon. That wouldn't have saved it even before, but because we've relocated the project, I've just imported this DWG now, so it sits in the right location. And then when we go back to CAD, we'll just like make a quick change. So I don't know, let's say for instance that this text here, because I want to add this later on or something, I'll put this on that new annotation layer created, which then hides it. Yep, turned off layer, that's fine. Save that file, go back to Revit, open up my manage links, click on the CAD file, reload. Okay, and you can see that's updated now and the CAD file is back in its original position. So it's not optimal, but once you, this is because we were relocating and rotating the project, changing its levels after we had built. If you refer back to like class 1, I said it's not good habit to do that. You can't avoid it. Some projects you may just not get this survey file until 3 weeks into design development, and so you've been modeling away. You can't not model until you get that information, but when you get it, you need to realign your model to do so. So it happens from time to time, and this is good because it shows you that workflow of what that looks like. The important thing is just to make sure you save a file before you start meddling around with its coordinates and whatnot. Now, granted, you may have to watch this component or this last component of this tutorial a few times, and that's totally fine. This massing and site component, and particularly project location, again, this is not really left normally just to a standard Revit user. It's usually a BIM manager or a digital engineering manager that works through this at the start of a project. And it's saying that you really only do at the start of it. Well, it is saying you do it at the start of every project. So if you only work on 2 projects a year or 3 projects a year, you're only going to be using those tools once or twice a year. So it's very easy for you to forget and then need to refresh it next time you go through it again, if you're not setting up projects every day. All right, so the last component that I'll go through here is site boundaries. This is a pretty cool tool as well. So I'm going to go to my massing and site tab, and underneath model site, I'm going to click on this tiny little arrow here, and I'm just going to change the angle display from degrees from north-south to just pure degrees, like that. And then I'm going to say OK. You'll see it's not going to make that much of a difference, just follow along, but we wouldn't be able to do this if we didn't have that. So I'm going to take these boundary coordinates, the bearings and the distances, so 89 degrees, 33 seconds, so 89 degrees, 33 minutes, and no seconds there, and 15.24 meters. I'm going to just Drag this over here for reference. And I'm going to go into Revit and click on property line. And it's going to ask me how I want to make a property line. Do I want to do it by entering the bearings and the distance, or by sketch? By sketch is pretty simple. I can just pick those lines. I can go on my sketch palette, pick these lines like that, and then say OK. And it creates those property boundary lines. So if I isolate them, they look like this. And we'll change how they appear, but there's nothing too intelligent about that. But a better way to do it, and a way that I know is more accurate, is to type in the bearing distances. So I'm going to go property line, create by entering the bearing distance. So firstly, the distance of the first line is 15.240, 15.24 meters. And the bearing is 89 degrees and 33 minutes. All right, and then I say insert another line. So I'm going from the top, the north boundary, like the boundary at the front of the property, and then working around clockwise. So then the second one is a distance of 134.50. No, it's not. 38.620, 38 meters. And then we're looking at, what are we looking at? 178 degrees, 43 minutes, and 30 seconds. Insert. What's the bottom one? Distance is 15.240, 269. 22 degrees, 22 minutes, 30 seconds. And last boundary. Insert. 38.670, 358 degrees, 43 minutes, and 30 seconds. Okay, so I'll then go OK, and that's complete. And you can see I'm holding that property boundary, and I can place that in a certain location. So I find the corner of that property, I go there, and then I've got my title boundary complete. So you'll see there it is there over the top of my drawing. So if I just hide the CAD file for a second, that is, and it goes to show how it's sitting over the top of our topography, that is actually our title boundary for the property. Now what's really cool about that is I can tag that. I can go TG on my keyboard, click on that property boundary, I'll remove the leader, and it's actually reporting to us the degrees, minutes, and seconds, as well as the distance of that boundary. So again, it's not dumb text. It's actually reporting real metadata from our site.